Good students and seekers of general truths, let us continue our work here with integration of complicated expressions. And you can see here we have another problem that will require some type of partial fraction decomposition. But before we get to that, I want to point out here to you, you should think and reason for yourself, why does integration by substitution not work? All right, so a lot of people will look at this problem and try to integrate it by substitution. But one of the problems is that the derivative of the bottom is not really a clean multiple of the top. Right? So reason through yourself through, like, why do other integration methods fail in this case? All right. And with that, I can show you how to use partial fraction decomposition here. So we're going to do the same thing as we did previously. We're going to set this expression equal to, notice that the denominator is neatly factorable. So we end up with 3x plus 8 over x plus 4, x plus 3 dx. All right. And let's solve and figure out what is the decomposition of this entire fraction. So it's some mysterious expression a over x plus 4 plus some mysterious expression b over x plus 3 is equal to 3x plus 8 over x plus 4 times x plus 3. Now we can do what we did before. Let's just multiply this by x plus 3 over x plus 3 and multiply this by x plus 4 over x plus 4 so that we get all of the same denominator. And once we have the same denominator, we can wipe out, we can really ignore it. So this expression on the left side becomes a times x plus 3 plus b times x plus 4, and all of this is equal to 3x plus 8. Okay. So expanding and simplifying the left side, we have ax plus bx, so a times x, b times x, plus 3a plus 4b. Okay, so I've distributed and just rearranged some things, and that's still equal to 3x plus 8. Now I can factor out the x, and I get a plus b is equal to x. Excuse me, a plus b times x plus 3a plus 4b. And that's equal to 3x plus 8. And once again, what we have here is a linear expression on the left side with a plus b as the coefficient of x, and a linear expression on the right side with 3 as the coefficient of x. So that tells us that a plus b must be equal to 3. And then the constant expressions is 3a plus 4b on the left side, and that must be equal to 8. Okay. So 3a plus 4b I'm going to write it underneath here. Uh, 3a plus 4b must be equal to 8. Okay. All right, so now I have a systems of equation, and all I really need to do here is solve for a and b. So if you remember, we're going to, from your good old days of Algebra 1 or maybe Algebra 2, to solve this, you can do it by substitution, or you can also do it by elimination. I'm going to go with elimination here just to mix things up a little bit. So I'm going to multiply the entire top by -3, and then I'm going to add all of that up. Okay, so this here will give me -3a minus 3b is equal to -9. In the denominator, the lower equation here, positive 3a plus 4b is equal to 8. And if I add the top and the bottom, the a's go away, and the b turns out to be, I get b is equal to -1. All right? And if b is equal to -1, then I can substitute it back into here, and I get that 3a plus 4 times -1 is equal to 8. So 3a minus 4 is equal to 8. And that tells me that add 4 divided by 3, 12 divided by 3 is 4. So a is equal to 4. Okay. So now, that again represents all of the hard part, the messy part. Now comes the good stuff, which is we could take what we know from this composition and apply it to calculating our antiderivative. This entire expression is really equal to a over x plus 4, but we know that a was equal to 4, plus b over x plus 3, but we know that b is -1. So we can say minus 1 over x plus 3 dx. Taking the antiderivative, we get 4 natural log of x plus 4 minus natural log of x plus 3 plus a constant. And there you have it, the solution to another tricky integration problem. As always, ask for help when you need it. Thank you for watching, and have a wonderful day.